Hello and welcome back to Biology from Jay's house. Let's see, I didn't collect homework, I didn't go over homework, but I know what you guys are thinking. Jay sure talks a lot, but what's the point? Let's go to the right and write the date. I believe this is supposed to be happening on the 18th. So again, as always, if that's not the right date, put the right date. Skip along, go all the way to the left, write the point. And it's what do the pancreas and liver do? So I'm not going to make you know a ton about the pancreas and liver. This is really just going to be an overview of those. You can spend your entire life studying either of those. So we're just going to kind of touch the surface. Let's take a couple notes just to get it started. So the first thing we're going to write is the pancreas. And that is an organ that makes insulin and glucagon, which help control the sugar levels in your blood. And clearly we'll talk a lot more about that, but let's keep going with the notes. Last note is liver. Now, technically, the liver does over 500 things in your body. So this is a very, very, very abbreviated definition of the liver. It makes bile and filters drugs and poisons out of the blood. So the pancreas and liver are not super related. The reason that they are being put together in one lesson is more that they are spatially related. They live right next to each other, and they tend to do their jobs more or less at the same time in relation to the digestive system. But their jobs are actually pretty different. So we are going to put them in the same lesson, but we're definitely going to think of this as a two-part lesson. We're going to think of it as first we do the pancreas, then we do the liver, and they don't really go together a ton. So pause the video and take these notes. So 3, 2, 1, pause. Welcome back. Okay, let's talk about first where this all happens. So if we think of the human body, so you got a neck, there's a head up there, you have, shoulders and arms, and we're into the torso, right? What you would see is you would see a big, like diagonal or triangular looking thing that comes in two lobes. So there's this kind of, it's like segmented. It has like a little like wall in the middle, and this is called your liver. So that's the thing that makes bile and does 500 other jobs, and also filters out drugs and medicines and poisons. And then living under it is a little guy that looks kind of like that, kind of like a tadpole. It has a larger end and it has a smaller end, and that is your pancreas. So the reason that I'm drawing it as the dashed line is because it lives under the liver. So I'd have to like lift the liver up and then be right under there. But I can't lift the picture up, so we do the dashed lines. And it's worth pointing out that both of these things dump out into the small intestine right at the top. So if we think about the digestive system, coming down, you have your esophagus, and then it connects to your stomach, which kind of comes around a bit like this. And then right at the top is where the small intestine starts. So I'm going to erase some of this, and we're going to go into the small intestine, and let me draw an accurate depiction of your small intestine. Okay, and let's dash line that. So thinking about, there's your stomach. And here's your small intestine. So the food never actually touches the liver or the pancreas. It just does not touch it. It only goes through the stomach and into the small intestine. In fact, the top of the small intestine is where everything kind of meets from the pancreas and the liver. So there's a little duct, a little tube called I believe it's called the duct of Oddi, if I remember correctly. And attached to it, the first thing that's attached to it is a little sac, and that's called a gallbladder. Now, you don't need to know about the gallbladder, except that the gallbladder then attaches to the liver and the pancreas. So what that allows the liver to do is the liver can make its chemicals all day and fill them up into the gallbladder. And then when food comes down, the gallbladder squeezes and pushes all those gastric juices, all that bile and all the stuff we're going to talk about, into the top of the small intestine. And that way the liver doesn't have to make a ton of it all at once. It can just kind of make it all day, and the gallbladder can just hold on to it until we eat. And when the food comes out of the stomach into the small intestine, the gallbladder can just squeeze, shoot all of its chemicals into the small intestine when the food passes by, and then off it goes. So the top of the small intestine, because it has this little duct right here and it doesn't do any absorbing right at the top, so this little section right here of the small intestine actually is called the duodenum. You don't need to know that, but it's worth pointing out, for the completist out there, that this actually gets a different name because this very, very top part where the stuff from the liver, the stuff from the pancreas, stuff from the gallbladder all pours in is called, and it doesn't absorb nutrients, so it gets a different name. Once it kind of rounds this first turn, it becomes small intestine, and then we're off to the races. So the point of this little section here is just to show us where in the body we are. Now, let's get talking about stuff. Okay, so we're going to start with the pancreas. Pancreas, again, it looks a bit like a tadpole, that kind of a thing. And what happens is it makes insulin and glucagon. Now, you don't necessarily need to know insulin and glucagon, but what they do is, if you remember, the point of all of this is to load up the blood with two things, with water and nutrients. That's why we have a digestive system, right? Well, part of those nutrients is sugar, right? And if you have too much sugar, then what ends up happening is you end up getting kind of manic. You get hyper and that sort of thing, and you have a lot of energy that's available to your body that we actually want to store till later. And if you have too little sugar, then you get really lethargic and tired. And if we think of the blood, and we think of the sugar that is dissolved in it, so that would be in the plasma of the blood. If we say if it's too low, if the sugar is too low, then we're tired. Or if it gets really bad, we can slip into a coma. Hopefully that never happens. But if the sugar gets too low, we're tired. So we need something to bump the sugar up if we don't have enough sugar. Oh, glucagon. So what happens is the pancreas then makes glucagon, dumps it into the blood, and glucagon is sugar basically. And it bumps that sugar back up so it's not too low, so we're not tired anymore. And glucagon raises sugar levels. Sweet. So if I haven't eaten in a while and I don't have access to food right now and I'm getting really lethargic, my pancreas can release some glucagon, bump me up, give me a little more energy, bump up my sugar in my blood, and we'll be good. But what if the sugar is too high? What if I just got back from... What if the sugar is now too high and now I'm hyper and I'm actually useless? None of my energy, there's a word called manic. I'm crazy, not thinking straight. My brain is firing 1,000,000 miles an hour. I have a lot of energy. It's hard for me to sit still. I'm just crazy town. How am I going to... That's not a good place to be either. In that case, the pancreas makes insulin, drops that into the blood, and what that's going to do is that's going to lower my sugar level. That's going to bring me back down. That's going to keep me from being hyper or manic. So the pancreas can raise blood sugar if I'm low, I haven't eaten recently. It can lower blood sugar if I have eaten, but I've eaten poorly. I decided, what's a dozen Twinkies really? Delicious. So my pancreas, which lives under my liver, can manage my blood sugar and make sure that I have the right amount of sugar so that I can be alive, awake, but not too hyper, right? Too high, I'm going to be hyper and I'm not going to be super useful. Too low, I'm going to be too tired, right? So if it's too high, I release insulin and it lowers back down to a good spot. If I'm too low, it releases glucagon and it raises to a good spot. And there's really just a certain amount of blood sugar that's good for me. And if you struggle with that, that is called diabetes. Diabetes is when your pancreas, it's an issue of the pancreas, doesn't manage this stuff correctly. So, and that can be life-threatening. And that means you have to manage your diet and you have to check your blood sugar yourself because this is not functioning correctly, or the mechanism interacting with the pancreas is not functioning correctly. So that's the pancreas. That's the main thing that I want to talk about with the pancreas, blood sugar. Now, do you need to know all this? No. I just want you to know the pancreas exists and that it can raise or lower blood sugar, the sugar that's actually in your blood, by releasing the right chemicals. You don't need to memorize the chemicals. You don't need to memorize which does what. But it's nice to know that there's two separate chemicals and one will raise and one will lower it. Oh, before I get beyond, so if you struggle with diabetes, if that's something that you have, you carry insulin around in case your blood sugar is too high. You can give yourself insulin shots, but you don't carry glucagon around. And why not? Well, if your sugar is too low, you just eat candy. So the two things that diabetics usually have are insulin to lower their blood sugar if their blood sugar spikes, and candy to do the job of glucagon, but candy is much cheaper and readily available, so let's just use that. So those are the two things that diabetics will always have on them if they have severe diabetes. Okay, pancreas. We're going to call that done. We'll just check that off. Check. And that has to do with blood sugar. Now, to understand the liver, we got to think about where this is happening in the body again. So let's say we have the stomach right here coming out. There's our big stomach. And what is the stomach full of? Oh, that's right. Hydrochloric acid. It is literally acid. Let me just write that to the side so you can actually read it. I can't see that super well on camera, but that says acid. That looks like acid. I'm just going to keep moving. Now, your stomach, if you remember when we first talked about it, it has a lining of something that protects it from the acid so that the acid doesn't eat the stomach away. And what is that lining? Hopefully you're all screaming mucus. That is correct. It's totally lined with mucus. It makes its own mucus, and that mucus goes between the acid and the stomach, and it's just a little barrier keeping the acid from eating the stomach away. Well, that's awesome. Isn't that well thought out? Well, what about when we leave? And remember, there's a sphincter here, worth pointing out. And a sphincter is anything that can, of course, open and close. So when it's open, material can pass right through it. When it's closed, it shuts off. So there's a sphincter right there. And worth pointing out, once material passes through here, it can no longer be vomited up. So once you pass through here, you are going to be in the body until you exit through the bum. That's right. You're going to take the full carnival ride. So the stomach is the last place where if something is really terrible in your body and it's in your stomach, you can still vomit it up and get rid of it on the shortcut and keep it out of the rest of your system. But once it passes right through there, that little sphincter at the bottom of the stomach, once it passes through here, it is going to take that 20-foot path through your small intestine, the kind of 3-foot path through your large intestine, and could do more damage. So that's why sometimes if you've ingested bad things, they'll tell you to vomit them up. Ask someone before you decide to start making yourself vomit, right? Call the Center for Disease Control and all that good stuff, and they'll tell you whether that's a good idea or not. But once it passes through this little sphincter, it's going to be in your body until it exits through your bum, or your anus, if you want to be accurate. So, okay, you have all this acid. Now, as you might guess, when this sphincter opens, not only does the food come out, but the acid comes out too. Well, we can't line this with mucus, because if we line this with mucus, what would it do? It would actually block nutrients from getting into the blood, because lining all of this on the outside is going to be your blood vessels, specifically your capillaries. Right? And we want nutrients to go from the small intestine into the blood. That's the whole purpose of the small intestine, right? And as you might guess, if there was mucus lining this, like in your stomach, the nutrients wouldn't be able to get into the blood. So we can't line it with mucus like we do with our stomach to keep it safe. So how do we keep this acid from hurting our small intestine, right? Because remember, this is our small intestine. Well, we can't line it with anything. We can't put a protective coat on it. But you know what we can do is we could turn it off. And there's a chemical that you can add to acid that turns the acid off. It makes it so it doesn't burn anymore. And that is called bile. Now, bile does other things too. It also makes the nutrients easier to get out. It kind of pulls the nutrients out of the food, makes it easier to absorb. So bile has a couple jobs, but the job I really want you guys to focus on is the fact that it turns off acid. And that way, as the acid, when it first enters the small intestine from the stomach, it's very acidic. It can very much burn you. Sure, it's been mixed with food, so it's not as strong. It's been diluted, but it can still do pretty major damage to your small intestine. So what do we immediately do right at the top of the small intestine? One of the reasons it gets the name duodenum, and that is we add bile, and that shuts that acid off. And now what is left can flow through the small intestine without burning anything. The acid's been turned off. If you know anything about acids, that means that bile is a base, because bases turn off acids. They shut them down. And I wonder, what makes bile? Well, if I look at my definition, the liver does. The liver makes bile. In fact, it makes it all day and throws it into the gallbladder. Do I need to know gallbladder? No, you don't need to know gallbladder. It's just a sac. It's just literally an empty bag that fills up with bile. And that way when the food comes in mixed in with the acid, it just squeezes it and dumps it all in right at the top of the small intestine, right when it leaves the stomach, so that the acid is turned off for its big, long 20-foot journey down the small intestine. So one of the things that the liver does, and the reason that it connects to the digestive system right here, right at the top of the small intestine and just past the stomach, is so that it can turn that acid off nice and early. So one thing it does is it makes bile, which turns the acid off. Now, the other thing it does is, well, the other of the 500 plus jobs that it has. So let's draw a liver. It's going to look a little something like this. There you go. That's the liver. So we already know, and I'll just write it at the top to remind ourselves that it makes bile. So I'll just leave that up there to remind ourselves that it turns acid off. So acid doesn't hurt us. The other thing is from the small intestine. So let me draw a correct depiction of your small intestine again. Yep, that looks about right. So the small intestine absorbs any nutrients that it can, whether it should or not. So things like medication are also absorbed here. Some medications are absorbed here. Some are absorbed other places, but it's medication. You also get, there's poisons and drugs that can be absorbed here along with other places. So one of the first things that happens is when the blood leaves the small intestine, the first place the blood goes is the liver. And if you could only think of one job of the liver, what I would like you to think of it is as a filter. So the small intestine and the large intestine, which absorbs water and water-soluble stuff, so things like salts that can dissolve in water, when all that stuff gets absorbed, the first place it goes to the liver so the liver can filter it. So the liver can pull out and package. Oh, sorry, picked a bad color. Let's pick a good color this time. There's a good color. So it'll pull out poisons and hold on to it and package it to be released. It'll pull out drugs that shouldn't be there. And it'll also pull out, it can pull out things like medications, right? So if you're on a lot of medications, you can actually harm your liver, and that's one of the reasons that doctors don't give us tons of medications when we feel sick, because they don't want to hurt our liver, because it's the liver that pulls it out and kind of gets it ready and can release it back into the bloodstream if need be. And so this is the blood that comes in is I like to think of it as unfiltered. And it's completely unfiltered blood. It's the pure raw stuff. It's everything that's been absorbed by the small intestine and large intestine. It goes into the liver. The liver pulls poisons out. It pulls drugs out. It pulls meds out. And then fresh or filtered blood enters your body. So probably the biggest job of the liver is actually to filter out all the stuff that the small intestine and large intestine absorb, because they do not do any checks. I mean, you can think of it as like that child's game where it's like, if the round, peg can go through the round hole, then the round peg's going through the round hole. Even if that round peg is black tar heroin, it's going through if it can, consarn it. So the small intestine, all this stuff along with the large intestine does not check anything. If it can be absorbed, it'll absorb it and just say, we'll let the liver, the filter, take care of anything that, shouldn't be there. So just like how your heart is a dumb pump, the small intestine is a dumb absorber. Doesn't really check for anything. It just absorbs endlessly. And then the blood immediately, absorb means it takes anything it can, throws it into the blood, and that blood immediately, without going to any cells, goes straight to the liver so the liver can filter out the stuff that shouldn't be there. And then the blood coming out of the liver, that's the good stuff, right? That's where stuff that shouldn't be there goes. And also medications, a lot of them need to kind of be unpacked, and so they become unpacked, and then the part of the medication that needs to be released would be in this blood also. So fresh blood doesn't just include cleaned out filtered blood, but it can also include aspects of medication that are good, right? And that's why if you eat poisons or low-grade poisons like alcohol or drugs, right? Those are low-grade poisons. If you do a lot of those, you'll actually end up having liver damage. You will actually break your filter. And as you might guess, having unfiltered blood flow through your entire system is a really bad thing. Also, if you break the filter, don't forget about the 500 other jobs it does. Those aren't getting done either. So liver failure is a really normal response to people who don't treat their bodies well and do a lot of alcohol or a lot of drugs. So again, as a teacher and as a human, really watch the stuff going into your body. It can have really huge effects if you don't, manage it properly. So I know I put bile up here. I also am going to put filter up there too. Now, does this describe absolutely everything the pancreas and the liver do? No, it does not. It just kind of gets the absolute basic, bottom, such as the pancreas also makes bile. So the pancreas also does that. But I don't want to, cloud the situation too much. So I'm kind of sticking with the basics here. So that's all you need to know for this class. Again, you could spend your entire life studying both the pancreas and liver, and people have, and they've gotten really smart at it. And there's still stuff we don't know. So this is not a complete lesson about pancreas and liver. It's just a real brief introduction. So now let's answer the point. What does the pancreas do? So the pancreas controls the amount of sugar in your blood. Along with other things, it also makes bile, but we're not talking about that. And what does the liver do? 500 jobs. I'd like you to list them all now. Just kidding. The liver turns off stomach acid. The technical term for turning something off is neutralizing. So you could say the liver neutralizes stomach acid. Remember, that's done by the bile. That's one of the reasons we make bile. And filters out harmful, I'm just going to write things from the blood. And those harmful things are things that were absorbed primarily by the small intestine and the large intestine, also stomach and other places. Basically, the body knows what blood hasn't been filtered and sends it to the liver first. And then out of the liver, it will end up going to all the places it needs to go. So there's 3 tasks here. The pancreas manages blood sugar. That's task number 1. The liver makes bile, which turns off stomach acid. That's task number 2. And the liver filters out things that shouldn't be in your blood. That's task number 3. 3 jobs spread between 2 organs. Well, there it is. As always, good luck.